Hello YouTube, this is Mr. Bakari, and today we are going to solve side-side angle triangles using the law of sines. So what we run into here is this ambiguous case, and what that is based on the values that were given, we could potentially have no solution, one solution, or two solutions. And when I say solutions, I mean what kind of triangles we can construct, 0, 1, or 2. Okay, and so what we have to do to figure that out is we basically look at the relationship of the opposite side of the angle given and the height. Okay, so these are all side-side angle triangles. So that's when we have to look at this. So if we compare side A, which is opposite of our angle, to the height that I've drawn here in orange, you can see that if the opposite side A is shorter than the height, we cannot close the triangle. So this would give us no solution. Okay? So there's no triangle to solve for. Now, in the middle here, we have a scenario where the opposite side of our angle A is the same length as the height. In this case, we have one solution. We have a right triangle. And then the third scenario is that side A, which is opposite of our given angle, is longer than the height. And if it's longer than the height, we can swing this down and we can close the triangle and it creates an acute triangle, but we can also swing it around. And as you can see, it's longer than the height, and then it comes and swings around and creates an obtuse triangle as well. So that's how we have two solutions. Okay? Now, how do we figure this out? Well, I've put together this flowchart that I like to use. And in the flowchart, we've got two scenarios. We've got a side-side angle acute triangle and a side-side angle obtuse. So let's look up top first. Now, how we navigate this is if we have an acute triangle, we have to look at the relationship of A and B. A is always the side across from the angle given, and B is the non-corresponding side. Okay, so if A is greater than B, you have one solution, you apply the law of sines, and you solve the triangle. Okay? If A is less than B, then you have to look at the relationship of A versus H. And we've got three scenarios here. I just went over on the previous slide, which if A is less than H, we have no solution. We cannot construct a triangle. If A is equal to H, we have one solution. And if A is greater than H, we have two solutions. We have an acute and an obtuse triangle. Okay? Now looking at the bottom of the chart, the way we look at this is we have an obtuse triangle. Now I realize this is not drawn to scale. That is an acute angle, but I just dropped a triangle there, call it obtuse. It's 126 degrees, so just kind of go with me on that. So we have an obtuse triangle. We look at the relationship of A and B. Once again, if A is greater than B, we have one solution. We just carry on. We use the law of sines and we solve. If A is less than B, we do not have a solution. Okay? So that's how we navigate it. So what we're going to do is we're going to look at a few triangles here. And all we want to do here is use the chart and determine if we have none, one, or two solutions. Because you got to get that down first before you can go and solve these. So the orange line is a height. All right, so I'll just put an H next to it. All right, and we're going to practice using this flow chart that I've got up here in the right-hand corner. So we have an obtuse triangle here, 118 degrees. So I'm going to look at the bottom at our obtuse triangle. If we look at the relationship of A and B, you can see that B is bigger. And if B is greater than A, we have no solution. So that is no solution. Okay, so if we look at the next one, this is acute, so we're going to go up top and look at our acute triangle. We are looking at A versus B. Here you can see B is bigger. So if B is bigger, we have to look at the height, okay? So to determine the height of the triangle, we're going to take sine of 41 degrees. And sine of 41 is h over 14, right? So if we get h over 14, we could go ahead and multiply both sides by 14, and the height is equal to the sine of 41 degrees times 14. Okay? So I'm going to put that in my calculator and figure out what the height is here. So I've got 14 times sine of 41 degrees, and I'll just round this to the nearest hundredth place. I get 9.18. Okay, once I determine the height, I compare the height to side A, and A is bigger. So up here in my chart in blue, if A is bigger than the height, I've got two solutions. Okay? All right, let's look at the third one. This one is obtuse again, so I'm looking at the bottom. This time A is greater than B, so I have one solution. All right, now looking at the last one, again, we have an acute triangle, so I'll go back up top. B is greater than A. So now I have to look at A versus the height again. So I've got to find the height. The height here is going to equal sine of 38 degrees times 12. Okay? So I will go ahead and put that in my calculator one more time. And I get 12 times sine of 38 degrees, which gives me 7.39. 7.39. And as you can see, the height is greater than A. And if the height is greater than A, we have no solution. Okay, so that's how we use the chart. Now let's practice solving these. So what we're going to do is I'm going to use this example, and we're going to solve for our two solutions. That is our acute triangle and our obtuse triangle. So I've brought this over here for us. This is just the same one I was just looking at. We've determined we have two solutions. So now we're going to go ahead and find those. So let's get started here. So what I'm going to do first is I'm going to use the law of sines and find my missing pieces here. Now, you'll notice that we're looking for angle B, angle C, and side C, and I've got two blanks next to each. So we'll call the first one our acute triangle, and this will be our obtuse triangle. Okay? So here we go. Go ahead and do this in red. So I'm going to use the sine of 41 degrees over the opposite side, 10, equals the sine of, and I'm looking for B, over its opposite side, which is 14. Okay, so that's the law of sines. Now, I've got to isolate sine B. So if I do that, I'm going to get sine B equals 14 times sine of 41 degrees divided by 10. Okay? So I've got to use inverse sine because I'm looking for the angle. So I'm going to go inverse sine, and I'm going to plug this in right here into my calculator. So let's go ahead and grab our calculator and do that. So I'm going to go inverse sine, and up top, 14 times sine of 41 degrees divided by 10, and I get 66.71. So angle B is 66.71. All right. Now, I can go ahead and write that over here, 66.71. Now to find C, we just take these two and subtract them from 180 because all the angles of a triangle add up to 180. So let's go ahead and do that real quick. 180 minus 41 minus 66.71 equals 72.29. All right. So we're almost done here. Now we've got to find side C. So to find side C, I'm going to use the law of sines again. Okay? So I'm going to start with sine of 41 degrees again over its opposite side, 10 equals, and now this time I've got to use sine of C, which is sine 72.29 over side C. Now I'm going to isolate C, which is going to give me 10 times sine of 72.29 divided by sine of 41 degrees. All right, so let's put that in our calculator. And we're going to go 10 times sine of 72.29 degrees divided by sine of 41 degrees. Make sure you type everything in correctly. 14.52. And that is our missing side. So now we have solved the acute triangle, but we know that there are two solutions, okay? So remember, you've got an acute and you've got an obtuse. So if I take this obtuse that I drew and I overlay it, you can see that the angle, 41 degrees, remains the same. Side B, 14, remains the same, and side A is 10. So those don't change. Okay, so what changes is angle C and side C and angle B. Okay, so we've got to find those. Now, the key here is remember, this is our swing side, and as we swing it over and create this obtuse triangle, this obtuse angle you see here, we create a linear pair. And what that means is 66.71 from 180, okay, these are angles, is going to give us our angle B in our second triangle, okay? So this is super important. This is how you start your second triangle. So if we take 180 minus 66.71, we get 113.29, okay? 113.29. And that is our angle B down here. And of course, it will be obtuse. And now if we take 41, which remains the same, and 113.29, we take that away from 180, we can find our third angle, which is angle C. And that gives us 25.71. Okay? All right. Now, the last thing we got to do is we got to find side C, and you can see this is going to be a lot smaller here. So we are going to use the law of sines one more time. Okay. So I'm going to go sine 41 once again, divided by its opposite side, equals, now I have to use angle C, which is sine of 25.71 divided by C. So now we are going to solve for C. C is equal to 10 times sine of 25.71 divided by sine of 41 degrees. And let's go ahead and put that in our calculator here. Let me clear this out. All right. Up top, we've got 10 times sine 25.71 degrees divided by sine of 41 degrees. And we get 6.61, which sounds right. And that is our last missing piece. And now we've solved for both triangles. Okay? So I hope this helps you out solving side-side angle triangles when you have the ambiguous case. Again, I encourage you to utilize the flowchart. I like looking at it just like this. If you look it up online, you'll see many ways of looking at this, but I like this layout. This is the way I present it to my kids in my classes. So I hope this helps you out, and I will see you in the next video.